Today we're going to start learning the second method of solving quadratics, which is the factoring method. And factoring is what we spent the last unit working on, factoring the different binomials, trinomials, four-term polynomials. There are three steps that we always start with. We always start with checking to see if anything needs to be simplified, rearranged, or if there are any greatest common factors that need to be removed. And so we're going to start by doing the same process on these. We're always going to check those three things just because it makes our life easier once we get to the factoring if things are already pulled out in the right format. So if the quadratic is a trinomial, we're going to use our b squared minus 4ac, our factor test, to find out how many solutions the quadratic will have with the discriminant and if it can be factored with the factor test. So if the quadratic is not a trinomial, you're going to check your factoring map and see if it's a special kind of binomial or if it's a four-term polynomial that can be factored. And you're going to go ahead and factor it in that way. Now, if it can be factored, you are going to set the quadratic equal to 0, and you're going to factor it. Once it's factored, you're going to set each factor equal to 0, and you're going to solve for x. And that's the process that we're going to use to solve these quadratics, or find the x-intercepts, or the roots or zeros, whatever you want to call them. So we have a couple examples here. So starting with the first one, so y is equal to x squared minus 4x minus 60. So first, we need to simplify, rearrange, remove any greatest common factors. It's in standard form. There's nothing to combine. We don't have a greatest common factor here. So we need to check the factor test and the discriminant to see if it can be factored and how many solutions it's going to have. So we're going to go ahead and look here. We've got A here is 1, B is negative 4, and C is negative 60. So if we plug that in as B squared, so negative 4 squared minus 4 times 1 times negative 60. We're going to simplify that in our calculator, and we get 256. So that is a square. It's also a number greater than 0, so that means it is going to have two solutions, and it is also factorable. Okay, so that gives us kind of an idea of where we need to go with this. So now that we have done that, we know that it can be factored, so we're going to take this quadratic and set it equal to 0 and factor it. So we're going to do x squared minus 4x minus 60, and instead of the y, we're going to look for where y is 0 because we're looking for x-intercepts, which means the y value of an x-intercept is 0. So we're going to replace this with the 0. So now we're going to factor this. And if you remember, we're going to use backwards FOIL. So we're looking for two numbers that multiply to equal negative 60 and add to equal negative 4. So when we start doing that, we're going to come across the numbers negative 10 and 6. Multiply, that equals negative 60. Added together, you get negative 4. So I'm going to be splitting this middle term. And I get x squared minus 10x plus 6x minus 60. I'm going to go ahead and group that. I'm going to pull out my greatest common factor of x, which leaves me with x minus 10. I'm going to pull out my greatest common factor of 6, which leaves me with x minus 10. And I have the two binomials, x minus 10 and x plus 6. Okay, so once it's factored, we're going to take each of the factors and set them equal to 0 and solve for x. So I have x minus 10 equals 0 and x plus 6 equals 0. So I'm going to go ahead and solve for x. I'm going to add 10, and I get x is 10, and I'm going to subtract 6, and I get x is negative 6. And so now my solution is going to be written as a solution set. X is equal to negative 6 and 10. Make sure I write those in least to greatest order. So that parabola, the parabola is going to cross the x-axis at the points negative 6 and negative 10 on the x-axis. All right, so another example here is 9x squared minus 79x minus 18. So on this one, of course, we start with simplify, rearrange, and remove greatest common factor. I don't have any of that to do here. So I'm going to go ahead and do my factor test and discriminant test. So A is 9, B is negative 79, C is negative 18. So I'm going to plug those values in. So I have negative 79 squared minus 4 times 9 times negative 18, which gives me 6,889. And I can take the square root of that. It's a square. Excuse me. So I find out that this has two solutions and it is factorable. Okay, so from here, I'm going to go ahead and start working on this. So I need to find two numbers that multiply to equal, let's see, I need to know what 9 times negative 18 is. So I'm looking for two numbers that multiply to equal negative 162 and then add together to equal negative 79. So 162 divided by 2, 2 and 81. So negative 81 and 2. If I multiply those, I get negative 162. If I add them together, I get negative 79. So those are the numbers that I'm going to use. Okay, so I have my trinomial here. So 9x squared minus 79x minus 18 is equal to 0. I'm going to split this middle term, and I get 9x squared minus 81x plus 2x minus 18. I'm going to group those and pull out my greatest common factors. I get 9x minus 9 and 2x minus 9. So I have x minus 9, and I have 9x plus 2. So I'm going to take those two, x minus 9 and set it equal to 0, and 9x plus 2 and set that equal to 0. And I'm going to solve those. So I'm going to add the 9. I get x is 9. I'm going to subtract 2 and divide by 9, and I get negative 2 ninths. And that's a fraction. I don't have to find the exact decimal for that. I can leave it just like that. And so I end up with the answer negative 2 ninths and positive 9. Right, and then from there, I have this third and final example. So here, I start with those steps again. Simplify, rearrange, or remove any greatest common factor. But on this one, I do have a greatest common factor. My greatest common factor here is x. So if I take out the x, I'm left with x minus 5. I divide both of those by x, and I'm left with x minus 5. So I don't have a trinomial here that needs to be factored. I don't even have a binomial that needs to be factored because my powers are 1. So at this point, I can go ahead and say that this has been factored, and I can set each of these factors equal to 0 and solve. So x is equal to 0, and x minus 5 is equal to 0. And so here, there's nothing to solve, and this one I add the 5, and I get x is 5. So my two answers here are going to be 0 and 5. It's going to cross the x-axis at 0 and at 5.